What we're going to be talking about today is the board that we're going to be using later on. Regardless now of the code, the breadboard, let's get familiar with the board itself. The board can get a power supply. Okay, this is usually you can plug it to your computer in real life, and you can utilize this for two things: for power plus to send your program and download it to the microcontroller. This is the microcontroller. The microcontroller inside here, this black one, okay? This is the brain of this board. So inside this, I can, I have the CPU. I can do all my programs, that I loaded to it. So let's say like this one here, I want to turn this on or off. Why? Because there is a code. This code later on we're gonna discuss it. Okay, this code I'm gonna send it through the USB and download it to the microcontroller. The microcontroller is gonna understand that code, okay, without going into complexity of this process. It's gonna understand that code, and based on that code is gonna function. So this is way much easier on me rather than hiring someone to turn this on or off. I can turn on off this based on my program. Okay, and this is one of the advantages of programming. It saves us time, it saves us money, and it is more reliable. Okay, easier to do, easier to implement. Now for this here, okay, this is the board. Okay, the board is an because it has electronics, therefore we need power. I said this is the power, we can get it from here. Once I got power, and now I have to get familiar with the pins, okay? But let me finish my idea regarding microcontroller first. The microcontroller, guys, as I said, is the brain. So if there is any problem with the code here, okay, I'm writing, the microcontroller is not going to function properly. So let's say a guy just invented a word. He said hello, okay, and put it there, and he's trying to run the program. Okay, it's gonna give us a problem. Okay, and later on we're gonna discuss the code. Okay, so we have to be familiar about the code. Also, we have to be careful about our code. We have to be careful not to damage this microcontroller. Could be damaged if we if we overload the board. Okay, so let's say I have only 5 volt and I'm connecting something to the board that needs more than 5 volt. This might damage the pin, or might end up burning your chip, or the chip get a static. You touch it from the back and it's not well protected. Depends on your situation here, circumstances. You might burn the chip. Okay, so this microcontroller here is the main part of the Arduino. Okay, another thing about the microcontroller, everything you see here is to help this microcontroller. So the microcontroller, let's assume it is like a brain. The brain, in order to give you commands to decide, it needs to get more inputs. So therefore, I have two things when I talk about microcontroller here. I have other than other stuff that we discussed. We have to think about inputs and outputs. Okay, input is something I, as a microcontroller, read. So the microcontroller reads something. So it is an input. It's a sensor, okay, that sends a signal to the microcontroller. So let's say I want to see what's the temperature. I have to provide the microcontroller with a sensor. So let's say here temperature. Later on we can study this. Okay, this is a sensor. I will connect it in a certain way, and it's gonna send a signal. Okay, it's gonna send a signal to the microcontroller. When I say a sensor, that means it's gonna send an input to the microcontroller. If I want to turn a light on like this one here, that means the microcontroller is sending a command, an output, to turn this on. So the question would be, how I'm going to know what is an input and what's an output? Every one of this is considered a pin. We call it a pin, okay? This pin is D13, D12. Okay, you can see it. They are numbered. Okay, this is a pin. I can get an LED. Okay, I can put it here, and it's plugged. Don't do this. Okay, but just I'm showing you. But it's better to use wires, and for sure you have to keep a resistor in series with LED. But you know, it's a pin. I can plug wires here. Okay, it's easier to plug wires this way rather than using a screw. So anyway, every pin of these guys is considered an input by default in most of the boards. Okay, if I want to use this as an output, like this one here, I'm using it as an output. I'm sending an output from this microcontroller to this pin. What does it do? It turns this pin on. That means it will allow the current to go through this. If I allow a current here, that means the current is high. If it is zero, nothing will work. If you take a look at the code, okay, I need pin number 9 to be an output. Okay, it has to be an output. Okay, and I have to be careful about these. While as an input, I don't care, because the default is an input. Now, what's this? What are these symbols? A ground is to tell me, hey, you look at it as a negative or a cathode for LED here. It's a negative. If I need positive, this is the positive. This is always positive, regardless what is the program inside the microcontroller. I always get 5 volts from here. I always get 3.3 volts from those are independent. As long as I have voltage coming, I'm feeding this with the proper power source, those will be on. I will get 5 volt and 3.3 volt, regardless of microcontroller. Okay? What's the difference between the voltage here, I'm having current here, and the current here? The current here is not programmable. It's always there. It's always supplying me. While here, I can control the gate. Let's call it a gate, okay? I can control it. I can turn it on, off, based on what? Based on microcontroller. More than that, I can make it either output using a code, or I can make it a sensor, okay? An input utilized for a sensor, okay? So this is here represent digital inputs. D stands for digital. Could be 0, could be 1, 0, 1, 0, 1. That's a digital. So digital could be like Boolean. Boolean is only one digit, one state, either 0 or 1. While a bunch of zeros or ones would be binary. So binary could be 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1. That's a binary. But Boolean would be, Boolean would be 0 or 1. That's it. True, false, high, low. Okay, you have to keep this in mind. So when I say D, that means I'm saying, hey, this is a digital. On the other side, I have something, we call it analog. Analog is not digital. Analog is like what? It's like, most of this stuff in our real life. It's not black or white, okay? Temperature. Temperature could be 0, could be 1, could be 10, could be 25, could be 100.6. So here we need analog, stuff. This is an analog. Can I utilize this for digital as well? Yes, you can, and you have to configure it in the code, okay? Later on, we can see some examples. So now we are familiar with the 5 volt, 3.3 volts. We are familiar with analogs, analog, and these are inputs. I read the analog. I can read what is the temperature in my room. I can use those, okay? For digital, it's designed for digital. Now, something about digital, I can see here D1, D2, D3, D4, but what's this symbol? This is telling me it is PWM, pulse width modulation. Okay, it is how far I can keep the pulse high. Okay, later on we can have a small, explanation about it. But just keep it in mind. If I wanna use pulse width modulation, so I can increase how long the current will be, I have to use PWM, like in our experiment here. Okay, because we said it's always 0 or 1. Okay, so it has to show me 0 1 0 1. So it's gonna be like a blinking. So why here it's not showing me 0 1, it's getting dimmer, then getting stronger. Okay, you can see this. Okay, it's not 0 1. So that means I'm using what? Pulse width modulation. Pulse width modulation. Okay, so I can extend, the duration of on and reduce the duration of off. And this is very beautiful. We can utilize it here. We can utilize it in servos later on. We can explain that later on, as I said. Now here I can reset the value. Be careful when you turn something on to see this is on. If you don't see it on, we have a problem. Another thing quickly, we have this RX, TX. RX means receiving, TX means transmitting. This is for serial communication. This is overall the main components that we are going to use in our Arduino. Let's take quickly about a pin, how to program it. Okay, this is the pin mode. I'm saying I need the number 9, pin number 9, to be an output. Okay, if you want it to be an output, therefore you have to write to that output. Okay, and that's what we are gonna be, as I said, doing later on. Why I'm using here in the code analog write? Because as I said, here we are not using pure digital. We are using a pulse. I needed to give me more duration as on. And this to be explained later on when we do some PWM examples. That's it for today. I hope you enjoyed it. Take care and have a good day.